Let us talk about the measures of central tendency using group data. So when we talk about measures of central tendency, it is just like finding the mean, median, and mode using ungroup data. Here we have group data, yet the formula or the formulas are quite different. So here we have the first one. This is the mean. To find out the formula of the mean, we have summation of fx all over n. Wherein this summation of fx, this refers to say we are going to multiply the frequency and the midpoint of the different class limits. And n is certainly, this is our total number of scores or cases given in the data distribution. Then in our median, we have this formula, the color green. The formula, we have the following denotation. This one, this is the exact lower limit where the median class belongs. Then we have the half of n. We are going to divide the total number of cases by 2. 2 is constant. Then CF, this is the ogive or the cumulative frequency below the median class. Then F here, this is the frequency of the median class. Then I is your class width. Then we have the mode. The mode is given by this formula. It's colored sky blue. We have the exact lower limit of the modal class added by d sub 1. This sub 1 is getting the difference of the highest frequency by its preceding frequency. Then d sub 2 here, this is the difference between the highest frequency and the succeeding frequency. Then I is your class interval or your class width. You can appreciate the values of these formulas if we are going to undertake this example. Okay, so let's have the following data set. We are going to compute the mean, median, and mode. So we have the following data here. We have the frequency, the class midpoint, the fx, and the cumulative frequency. Okay, I need to delete this part because we do not need this. So first, in finding your midpoint, we need to find out first our class midpoint. How do we find out the class midpoint? We are going to use the class limit. Okay, we are going to use the class limit as what I mentioned earlier in our uh, preparing a frequency distribution table. To find out the class midpoint is simply add the lower limit and the upper limit divided by 2 or get the average of your class limits. So the class midpoint or the midpoint from 40 to 44 is 42. Why 42? It's 42 because just add, wait, this is 42 because you just need to add 40 plus 44, then divided by 2. 40 plus 44 is 84, divided by 2 is 84. Together with this, 45 plus 49 divided by 2 is 94. Then, if you will divide it by 2, 94 by 2 is equal to 47. Together with this, 50 plus 54 is 104 divided by 2, that's equal to 52. As you notice in doing your class midpoint, you can easily see a pattern. So to find out the succeeding class midpoints, just need to add this by 5 because that is the class width of the given class limits. It's 5. So here we have 57, we have 62, we have 67, we have 72, we have 77, we have 82, we have 87, and we have 92. That's the shortcut, okay? That's the shortcut in determining the class midpoint. But always take note that you need to be very vigilant and you really have to work in precision because if there's one mistake, I tell you, it will be a domino effect. The succeeding solutions will also be a mistake. Okay, so you need to work with accuracy. Now, here, we are going to find out your n. Your n refers to the total of the frequencies. Just add them. So if we are going to add this, we have 1 plus 0 is 1, this is 4, this is 5, 8, 11, 20, 25, 27, 30. So it's equal to 30. So n is equal to 30. So by using the formula, we can put here now, your n is equal to 30. Okay, it's 30. Then next, we need to find out the summation of fx, this numerator here. Fx is simply multiplying the frequency and your class midpoint. We just need to multiply them. So here, the fx, or yes, the product of the frequency and the class midpoint of your class limit 40 to 44 is 1 times 42. You multiply this. So I'll be getting 42. Then you multiply this. This is equal to 0. Then the next, 3 times 52, that's equal to 156, right? 3 times 52 is 156. Okay. Then next, we have 0 times 57, that's obvious, is equal to 0. Then 1 multiplied by 62 is 62. Then 67 times 3, that's equal to 201. Then 72 times 3, that's equal to 216, right? So 116, you can use your calculator solving this. 77 times 9, that's equal to 693. Then 82 times 5, 82 times 5, that's 410. Then we still have the last two. 2 times 87, that's 174. Then we have 3 times 92. We have got the result is equal to 276. Next is, we are going to get the total of this. Find the sum. We need to add all together the different fx of different class limits. Okay, you need to add them. So we have 42 plus 0 plus 156 plus 0 plus 62 plus 201 plus 216 plus 693 plus 410 plus 174 plus 276. This is equal to 2230. That is now the value of summation of fx. Okay, remember that this sigma, this symbol sigma, if you see that, that denotes that you're going to add. You're going to find out the total. Now we have 2230. Okay, then we just need to get the quotient of this. Divide it by 30. So approximately the value of our mean is 74.33. This is the approximate value of our mean if you're going to round it in the nearest hundreds. So we have 74.33. If we are going to interpret the meaning of this 74.33 as the mean of our given data step, this means to say that, let's say, out of 30 students who took up, let's say, a test in math in the modern world, let's say out of 100 items, from the 30 students, all their scores are being represented by one common score, and that common score is 74.33. That's the meaning of mean. There is a common score among all the students. So that's how we describe the meaning of a mean. This is indicating a specific score that would presume the performance of these 30 students who took up, let's say, a specific test in math in the modern world. Okay, that's how simple finding our mean using group data. Remember that in determining your mean for group data is different from using the ungrouped data formula for mean. Next, let's go to median. Okay, the formula for median is given by this. We have your L sub MD. This means to say that this is the exact lower limit of the median class. But what does median class mean? Median class means to say that this is the specific class limit wherein you can you can find out your median in that specific class interval. Okay, so here in our example, how do we find out the median class? The median class can be determined by using your n over 2, this one. That n over 2 is very useful in determining your median class. Okay, so what is our n over 2? If we have our n which is equal to 30, that's equal to 15, correct? How did I get 15? I divided 30 by 2. 2 is constant, you cannot change that. Now, after getting your 15, we need to fill out this column, your cumulative frequency. When we say cumulative frequency, this is also known to be your ogive. A cumulative frequency is simply getting the sum or accumulating all the different frequencies of each of the different class limits. Okay, so let us try to find out your cumulative frequency. In symbol, this is usually represented by CF. Okay, if you will see that symbol, that means to say your CF or simply your ogive. Okay, so from 40 to 44, the frequency is 1. So you need to put here 1. Okay, that is equal to 1. Then next, the CF of 45 to 49 is just add 1 using the frequency of the next class limit. So 1 plus 0, it's 1. It's 1. Okay, it's 1. Then next, you add 1 again using the frequency of your next class limit ranging from 50 to 54, which is 3. So 1 plus 3 now is equal to 4. Then plus 0 is 4. Then plus 1 is 5. Plus 3 is 8. Then plus 3 is 11. Then after that plus 9 is 20, right? Okay, it's 20. Then plus 5 is 25. Plus 2 is 27. And plus 3, finally, we have 30. Here, one of the hints, if your cumulative frequency, the way how you computed it, if it is correct, your total CF, the last CF should be equal to the value of n. So here we have 30. It's 30, that's the CF. Then we have n here, it's also equal to 30. Okay, let us try to put some marks so that you will not be confused. These two should be the same, okay? They should always be equal. Because if they are not both equal, then there's something wrong in your computation. You have to recompute. Okay, so our CF, this column now is set. Next is, how do we find out our CF? As what I mentioned earlier, that CF is considering your n over 2. And our n over 2 is 15 because 30 divided by 2 is 15. Now, once we got 15, we are going to go to this column, your CF. Where can you find 15? 15 can be found in between the CF 11 and 20, correct? It can be found here. It can be found here. So 15 is ranging from 11 to 20. Yet, your median class now can be found at 20. Okay, I'll mark it. This is now our median class at 75 to 79. When we say median class, that is the class limit where the median belongs. Okay, so let us try to put that mark. Let's make it color black. Then let's use, let's say, color yellow. So this is our median class. I'll put here median class. Wait. No, that's the median class. I need not to write it. It will uh, disturb our table. Okay, so this is our median class. How did we get again your median class? You just have to divide your n by 2. Then, how did I get 20? You might be wondering, why 20, not 11, since 15 can be found between 11 and 20. It's basically given by the fact that your CF here, your cumulative frequency, should always be lower. We cannot use 20 here as CF because 15 minus 20 is negative 5 and it couldn't be. Our CF should always be lower than the value of n over 2. That's pretty obvious, okay? I'll repeat. To find out your CF is simply divide your n by 2 and your n over 2 should not always be having a CF greater than its value because that will be negative and that would be a mistake. That's why we have to use 20, not 11. Then, okay, let us use now the formula. So here, what is L sub MD? That is the exact lower limit. When we say exact lower limit, that is the class limit wherein you need to consider the lower limit. The lower limit here is 75, but we are going to find out the exact lower limit or the lower boundary. The exact lower limit or the lower boundary is 74.5, as what I mentioned in our preparation of frequency distribution table. You need to subtract your lower limit by 0.5, okay? Then here, we have n over 2, that's 15 minus, what's the CF? This is what I am trying to tell you. So your CF should not be greater than your n over 2. Because if you will be using 20, that is ultimately a mistake. Because you will be getting negative. So your CF here, this means to say that this is the cumulative frequency below the median class. Okay, here, where is below? This, it's 11. Okay, it's 11. Below it. Okay, we cannot use 25 because if you'll be using 25, it's already not below, but that is above. Why? Because if you're going to see your cumulative frequency, we start at 1, then it ascends. Okay? So when we say below, we expect that the value is lower. So 15 minus 11, I'm sorry. So 15 minus 11 over, what is the value of the F? This is the frequency of your median. What's the frequency of the median class? It's 9. This is 9. So you put 9. Then what's the class width? The class width is obviously equal to 5. That's the class interval. Okay, then let us copy this. Then let us simplify. Okay. So 15 minus 11 is equal to, what's the value? 15 minus 11 is equal to 4. Correct? So 15 minus 11 is equal to 4 over 9. Then, what's the next? We are going to simplify it. So we have 4 times 5. 4 times 5 is equal to 20 over 9. It's 20 over 9. So here we have 20 over 9. 20 over 9. Okay? We're almost done in getting it the value of the median. So here we have 74.5 plus, what is 20 divided by 9? 20 divided by 9 is approximately 2.22. That is the approximate value. So we have now the median. The median is equal to 74.5 plus 2.22 plus 74.5. So the value is 76.72 approximately. Because of what I did, I simply expressed the answer or rounded it off in the nearest hundreds. Okay, take note. It's 76.72. This is the value of our median. And based from the definition of median class, this is the class limit where you can find your median. Let us try to take a look. 76.72. Can we find it at 75 to 79? Can we find it? Yes, definitely. It is found. It is within the range of the median class. Okay, so our median is 76.72. Next, let's go to mode. So we have the formula of the mode. This is given by our mode here. This is the formula. So here, the modal class. How do we get the modal class? Okay, how do we get the modal class? We need not, we do not need this any longer. So here, let us just concentrate on the frequencies. So here, to find out your L sub MO, you are going to consider the class limit wherein it contains the highest frequency. What class limit contains the highest frequency? Based from our example, the highest frequency is 9, right? It's 9. Therefore, your modal class is along 75 to 79. Okay? We can find out your mode along 75 to 79. Then, after that, we are going to determine your D sub 1. As what I told you, your D sub 1 is the difference between the highest frequency and your preceding frequency. That's 3. Before 9, we have 3. Then, D sub 2 is getting the difference between your highest frequency and the succeeding frequency. We have 5. So here, we have 9 minus 3. This is 9 minus 3, which is equal to 6. Right? Then next, we have 9 minus 5, and that is absolutely equal to 4. So here, I'll repeat. To find out, let's say, your D sub 1, this is your D sub 1. Your D sub 1 is the difference between your highest frequency and the preceding frequency. So we have that part there. Here it goes. So that you will not be confused, let us try to put some color here. So let us put this is color brown, and this one, this is, let's say, color yellow. Okay, so this is the preceding, okay, preceding frequency. This is the next is the succeeding frequency. Okay, so D sub 1 is 9 using your highest frequency, 9 minus 3, so it's 6. Then your D sub 2, your highest frequency deducted by the succeeding frequency, and that's 5, so 9 minus 5, which is equal to 4. Then now, we're just going to replace this. So D sub 1 is equal to 6, then this is 6 plus 4, okay? 6 plus 4, then multiplied by 5. That is our class width. So here we have 6 all over 10. Then 6 times 5, that's equal to 30. Correct? It's equal to 30. And here, 30 divided by 10 is equal to 3. So we will be getting 77.5. This is now the value of our mode. It is equal to 77.5. So I'll repeat. To find out our mode, We just need to consider the formula. We are going to find the sum of the exact lower limit or the exact lower boundary of our modal class added by the quotient of d sub 1 over the sum of d1 and d2 multiplied by I. Again, to find out your d sub 1 is just subtract your highest frequency by the preceding frequency, and to find out your d sub 2 is you subtract the highest frequency by the succeeding frequency. Here, this is how did we resolve for 6. It's 9 minus 3 and 9 minus 5. That is our d sub 2. Okay, so we have here now the formula 74.5, but this is the exact lower limit of the modal class, plus 6, that's our d sub 1, then the sum of d sub 1 and d sub 2, which is 6 plus 4 times 5. So we have 6 over 10 times 5, so we have 30. 6 times 5 is 30 over 10, that's equal to 3. So our mode is 77.5. By inspection, 77.5 is still within the range of 75 to 79 because this is our modal class. Okay, so that's how we compute the mode, the median, and the mean using measures of central tendency using group data formulas. Thank you.